Cheers, Brian. Hi. Good, thanks. How are you?
Whole lot more sense.
Plenty of room at the front, just like church. How are you? Yeah. Let's go for it. All right. Because you're getting. Okay. Sorry.
Okay. Maybe I need, oh. So it was on, the red light was on, but I clicked it all the way over. So now things are much better. All right, welcome, ladies and gentlemen. And as I said, welcome to our DC PIC, Durham Catholic District School Board, focusing on fractions night. Thank you so much for joining us on this January evening. My name is Christine Corso. I am a teaching and learning consultant with our board. And this is Michael Jacobs, who is another numeracy consultant with our board. We also have Laura Sternad here, who is an elementary school facilitator in 3 of our elementary schools. We have Brian Chen at the back, who is one of our consultants. He does technology-enabled learning. We also have Rosemary Leclerc over here, who is our superintendent of DC PIC. We have Lori Jones, who is her administration assistant and is responsible for us to be all organized and have all the materials. So we really are very grateful to her. And we're also very grateful to our DC PIC, who has organized and has supported this evening. They've helped to orchestrate to make sure that there was childcare this evening, snacks, and all the materials, etc. So we're very grateful for that. As we get started this evening, as always, we have our land acknowledgement. So we here in the Durham region respectfully acknowledge that we are on the traditional lands of the Mississaugas of Scugog Island. And as we start all of our meetings in our board, we will say a prayer. And the intentions from on our behalf are for all the families of the students and staff in our board. And if there are any special intentions, you're more than welcome to share them with us. And for those intentions that we keep near and dear to our hearts, we will say a Hail Mary. In the name of the Father, Son, Holy Spirit, amen.
Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death. Amen.
All saints pray for us.
Okay, so this is our second evening, and I see some faces that were here from their first session. So back in November, Mary's, and tonight we are looking at focusing on fractions.
And we will have 2 more sessions. There is one on March 19th, and the focus on that will be on spatial reasoning and how that applies to numbers as well as objects and movement and those kinds of things. And then our last one will be at Monsignor Paul Dwyer High School in Oshawa, and that will be focusing on problem solving. So the ministry, you've probably heard in the last, since the new government has been formed, they released a document in the summertime called Focusing on Fundamentals. And there are 2 guides. There's one for teachers, and there is one for parents as well. The one for teachers is geared to K to 8, but it's applicable through all of, even into secondary. Within that document, there are 5 key fundamentals that the ministry has identified. The first one is working with numbers, the second being number properties, mastering math facts, developing mental math skills, and the last one is the proficiency with operations. So we'll talk a little bit about some of those this evening, but in particular how they relate to fractions. Our goal this evening, first of all, is to discuss and to really try and understand why fractions are so difficult and what are those small kind of pieces that we as parents can help our students and our children to look at and understand. We are also going to learn how we develop a deep understanding of fractions. So there's a couple of, we call them continuums, so where we might start and where we kind of progress to. So you'll kind of get some information there so that you may be able to kind of help your child either by going back a little bit or ahead a little bit to help them to understand that. And then most importantly is to learn how to help as parents.
So one of the things I want to kind of stress is that fractions are actually really difficult. And it's not just students who find them difficult. I work with adults and I often see misconceptions that they might have. But we also see mistakes being made in the media all the time. Now, whereas most of the time, Christine and I are going to be talking about fractions, it does extend to things like percentages and decimals as well. So you might something like this, and you see, should all high schools administer breathalyzer tests to students arriving at the prom? Well, as a father of someone who's gone into high school, I'm a bit concerned that we've been asking that question, but 45% say no, and 55% say yes. There's something a bit dodgy about that pie chart, okay? I know what a half looks like. I know 45% is less than a half, so yeah, that doesn't sit well with me. But then I saw something like this. Now, this does get the award for the worst graphic ever. I mean, so 20 million is a third of 60 million. So they got that bit right. But that isn't, that's been shaded. And I don't know why they've got a key down here which explains exactly what they've got up there anyway. That's like a waste of ink. You'll see it on the TV as well. Put your hands up when you see the mistake. And honestly, I sometimes wonder, why does nobody pick that up before it goes out to air? Okay, like, it's the wrong colour to begin with, okay? This 61%, that's definitely less than half in my world, but this 10% don't know, which is the smallest of all of these, that's got the biggest proportion. Why is this not picked up? But the funniest one I've heard, true story, I found it on the internet, so it must be true. In the 1980s, A&W wanted to kind of challenge the burger supremacy of McDonald's, and they thought, you know what, we'll make a bigger burger. They've got a quarter pounder, we're going to go for the third pounder. In all the testing, the taste was better. Yeah, people prefer the taste. They said, yeah, it was lovely, but why don't you want to buy it? Well, McDonald's is a quarter pounder. Yeah, ours is a third pounder. Well, yeah, it's smaller. And that was the feedback that they were getting. So people actually thought that a third was less than a quarter. Okay? It's a common misconception. One final story I will share. we were watching the American football, or football, I guess you call it here. Just 2 days ago, my son was watching it, and it's in the first quarter. I don't know if we should share this because it's quite embarrassing.
Is it embarrassing for you or your son?
For me.
But you can.
Yeah. Okay. And my son said, "Dad, how many quarters are there in a game?" And I went, "Your dad's a math consultant. Don't ask me that question. How many quarters do you think?" "Oh, I don't know, 2. I said, "No, there's a reason. There's a reason why we call them quarters." Okay? So he went to bed early with that. But fractions really are difficult. And one of the things that I like to do more learning about, I think I shared this at our last meeting, is this kind of CSI math. Why are kids making mistakes? So I just want you to look at this particular question here. It says convert to an improper fraction. That's a funny word, that, isn't it? An improper fraction, like it's done something wrong. So 3 and 5/11ths. Student has done this, and I get that. Is that correct? Yeah, a lot of people are saying, "Yeah, that's what I got. Is that wrong?" No, that's right. Okay. Does this kid understand fractions? Converting a mixed number to an improper fraction. Good to go? Yep. Okay, brilliant. Same kid was asked to put these fractions on a number line. So for those, see, this has 4/5, and between 0 and 1, they put it there. 1/7, between 0 and 1, they put it there. 3/8, put it there to begin with, and then they moved it there. The same student. That worries me. And I'm going to go back to what the student did there, because I find it's more interesting now. Yes, they ended up with the right fraction. They really have fractional understanding. So you might think, well, they've done some things there. I think there's evidence they've done 3 times 11. 1 plus 5, 33 plus 5 was 38. But I think all they're working with is just whole numbers. They've just learnt a rule. You do that times that, plus that, write it down, put a line, and put the thing underneath it. I don't know if they even realise that is actually the same quantity as this. So sometimes kids get the right answers, but for the wrong reasons. And we ask another simple question like this one, and that tells me they don't have a very good understanding of fractions at all, because they can't even show me where 1/7 is. So why do these misconceptions develop? Turn to somebody on your table and tell them how you say that fraction. Off you go.
There's chairs here. There's chairs.
Thank you. How do you say that fraction?
Over.
How do you say that fraction? 3/4? Can you say it? We say 3/4, most, yeah. Some people say 3/4. If you're a 3/4 sort of person. 3/4? Quarters? Okay. Have you ever come across people who say 3/4? Yeah? And like, if you understand fractions, you can get away with saying that. But if I said, what's that number? Nobody says 2 besides 7, do they? Okay, we say 27. We actually use place value in our language. Now, like, between you and me, if I'm speaking to people who know about fractions, I will sometimes say 3/4. But for a beginner, that's no good at all. And it's something, I'll be honest, I used to do a fair bit when I was teaching, and I realise now that led to some students' misconception. So one of the things we can do with parents is actually use the correct terminology and say 3/4 or 3/4, you feel more comfortable with. Other times, I think misconceptions develop because we show tricks which might work, but don't actually give kids the understanding of why things work. There's something which I see used, and it's called the butterfly method, and it's sometimes used for adding fractions. Now, it's quite possible that kids can use this to get the correct answer, but it's very possible that they use it and still not understand what's going on, and still not develop fractional understanding. And I also know that what happens if kids show this butterfly method, I'm not even going to begin to explain it to you because I'm not sure I understand it myself, okay, but they use the wrong situations. So be very careful if you're giving tricks. I don't mind tricks which people understand, but if the kids don't understand what's going on, it makes things difficult. And the other thing, and I'm guilty of this as well, sometimes we give rules that don't work. Have any of you heard of this rule? Whatever you do to the top, you got to do to the bottom. Hands up if you learned that at school. Hands up if you taught that. Okay. That only works in certain situations, if you're multiplying or dividing. And I remember one of my students actually said 2/3 is equal to 3/4. And I said, no, it's not. He goes, yes, it is. You told us whatever you do to the top, you do to the bottom. And I added 1 to the top and 1 to the bottom. So therefore, it must be equal. And I went, oh, no, that's not right. So sometimes as teachers or adults, we give rules that work in some situations, but not in every situation. So all these things combined mean that misconceptions can develop. So what's that look like? Well, we're going to give you some maths to do now. Okay? These are some questions from last summer's EQLO. And on the front of this was the 4 questions, 2 from the primary and 2 from the junior. And I know how much you love doing math. I'm going to give you about 3 or 4 minutes to do these. Don't worry, name on it. We're not collecting them in, okay? We're not marking them. But what I do want you to do is go through these, answer them yourselves, but think about what students might find difficult about these, okay?
Is there anyone that needs a pencil or a pen I can grab? There's some over here.
This is not a formal exam. You are allowed to talk, okay? So once you've got it, just compare your answers. But also just chat about what do you think kids might find difficult about these questions.
I reckon I can give you another minute or so. Is that any better? Right. So let's think about these then. Okay. So just for fits and giggles, what percentage of our grade 3 students provincially do you think got this question correct? 40%? 7%? Okay. 60%? It's actually 40%, which initially...
No, that's not something to cheer about. Like, I know you're right, and I'm really glad you're right. Like, yeah.
Initially, I thought that surprises me, okay? But then I thought, oh yeah, but I made a mistake on this question. Okay, I've been living here 18 years, and I'm still getting used to the money here. And I've got like bad eyes. And initially, when I looked at this, some of you might have thought that those were quarters, because it just doesn't make any sense to me at all why your 5-cent pieces are bigger than your 10-cent pieces. Okay, so I can see that some students are making mistakes on this, especially if they don't have the actual money in front of them, because that's when we tend to use money most. It's in front of you. It's a lot easier to make these distinctions and to flip it over and say, oh yeah, that's a quarter or whatever. But I think that's where some kids made mistakes there. But then in terms of what's going on, he spends $1.75. Okay, let's be honest. If you're spending $1.75, would you give all those coins?
Well, it could be one of those situations where, you know, like you have the stuff in your pocket and you just like dump it. You hope.
Yeah, we all do that.
Yeah,
No,
I don't
so
know either.
again, even the context of the question, I'm not so sure if it's a realistic context. $1.75, I'm going to give a tourney, and I'm going to expect 25 cents back. So there's a lot of extra stuff going on there, and I can see why that might trip up some students. Okay, but one of the things I will encourage you as parents to do, like in the past, we might have had penny jars. Yeah, and you collected the pennies, and you know you tip them all out, and the kids count them up, and that's great. The penny is obsolete, and after a while it gets boring counting by ones. But maybe have a silver jar, okay, and any spare change, nickels, dimes, quarters, put them in there, and after a while tip it out and get your sons or daughters to separate and to count. Now initially they'll count the 25, 50, 75, but after a while I think it'd be really good if you just pull 4 quarters and say, that's $1. And sometimes it's really neat when kids go, oh, 4 quarters make a whole. Is that why they're called quarters? Yeah, that's why they're called quarters. And that's a big, you know, moment for some kids. What percentage of kids do you think got this correct?
We're going with 40 here.
45? It's actually 77% of students. Yeah? So whereas they made mistakes here, and I think is maybe the type of question, when you look at this one, there's a fair amount of things going on. How many sparrows do she see? I know some kids are looking for the answer 2.5. I do know that. Okay? But then...
Not so good for the sparrow.
Yeah. Again, why are you using trees to represent birds? I'm not sure. But anyway, they figure it out. And it's, you know, it's not necessarily the simplest one for some kids to have, but whatever way they've done 6, 12, half of 6 is another 3, they've done 15. So I think that's pretty good. I'd be even happy as it's higher. But yeah, there's definitely some fractional understanding going on there. I want to just quickly look at this one. What percentage do you think got this correct? A bean plant grows 7/10 of a centimeter each day. Which length is the closest to the total growth? What percentage do you think got this correct? 20? 100?
I like your thinking.
So, optimistic, but wrong. Yeah. Lots of things going on here, isn't there? Okay. First of all, do we all know how many days there are in a month? Yeah. Yeah. It depends which month. It says closest to the top. We've got to begin to estimate a bit here. Our kids going to use 31 or 28 or 30. They might use all of them, but in the end, they've got to do approximately 30. Okay, and if they do that, they're going to get 21 centimeters. Did I get that right? Yes. Okay. 77% of our kids got that correct. 77%. So over 3/4. See what I did there? Over 3/4 of our kids got that correct. Yeah. So yeah, that's pretty good. Yeah, because there's lots of ways it can trip up there, but over 3/4 of our kids got that correct. I'm okay with that. But I find this one fascinating as well. Which decimal number is equivalent to 2/5? I almost said 2/5, but then I remembered. Which decimal number is equivalent to 2/5? It is this one here. Yeah, 0 and 4/10 or 40/100. I know some kids were looking for 0.4 and it wasn't there. And so they just guessed. All right, they didn't understand that 40/100 is the same as 4/10. But the most common wrong answer was this one here. Okay, because what some people do, even some adults, they see these two numbers. And if you say 5, they think it's 0.25. Okay? So one of the things that the curriculum asks us to do is to get these benchmarks that 1/5 is the same as 2/10, 2/5 is 4/10, and so on and so on. 65% of our students, our grade 6 students, got that correct. So it's not bad, but it's definitely a big misconception which we want to correct. So the question is, how do we correct these misconceptions?
And if you were at our last session, we talked about this continuum, and if not, we're going to talk about it here, and we'll talk about it at some of our other cafes as well. So when we are looking for a teaching strategy, one of the ways that we look to build understanding is to start concretely. So that's any sort of manipulatives or things that you actually do with your hands. We want kids to have a fractional experience there. So when you're at home and you are actually baking, that's a concrete. It's to understand fractional amounts. From there, we go to a diagram, so that now it's gone from something that they can actually physically maneuver to either they are drawing it, we are drawing it, they are seeing it on a board, etc. And then finally, we would go to what's called the symbolic. And that's where we have that fractional notation, where we have a numerator and a denominator. And for grade 3 is all the way into fractions in terms of these kinds of ideas. Grade 4 is where we get into the symbolic notation most frequently, and then it kind of continues from there. So, a teaching little tidbit for you. Homework with your son or your daughter, and they're having some struggles, and you're like, oh, we're looking at a picture. Getting it is to try and figure out, could I do something with concrete hands-on kind of things? Or if they're doing some work from a textbook and it's numbers that they're seeing, maybe to get them to go and draw a diagram. And if that kind of catches them on, great. Or then to go back and try and figure out how you could do it concretely. That might be something that you take a look at. So we're going to give you some examples of all of those things, because how are you supposed to know what to do? So we are also going to talk about a continuum where in the beginning we talk about unit fractions. So things like 1/2, 1/3. Okay, so you can hear that there is a unit in there. We will also then get into comparing fractions. So which fraction is larger, which fraction is smaller. So you can see where we would want kids to have a concrete experience with those things, rather than just for us to tell them that 1/4 and 1/3 and how to compare those two. If they can understand it concretely or diagrammatically, it's going to be much more helpful. And then the last part of our fraction continuum or our fraction learning pathway is operating with fractions. So adding fractions, subtracting, multiplying, and dividing. So you can see if you understand what unit fractions are, or you can compare fractions, that's going to help you with any of the operations that you would need to do. So we have also a variety of kinds of fractions. And so in our culture and in our environments, we see the area model lots. Okay, we have pizzas, like the notorious example for fractions. That is an area model. And frankly, if you've ever ordered a pizza, it's not very good for fractions because some of the eighths are bigger, right? Like they're, you know, you want the big slice of pizza. Well, then why are we talking and using that one as our understanding? So that's an area model. And this rectangle is a bit better of a go-to. Kids will find drawing a rectangle and dividing it into equal parts easier than a circle. We also have fractions of a set. And in our culture and in our environments, we have to do this one the least. So for example, when you look at this picture, we can talk about fractions. So now I can't use my understanding to talk about that taking up the same amount of space. So you can see where that can add to some confusion. We also do linear fractions. Tape measures, those kinds of things. We see those quite a lot in number lines and things like that. The other one that is here to both the area and the linear is volume. So right now I can see that some of you have 3/4 of a cup of water. Okay, so you can see where we might use that in our everyday life.
The linear one is a very important one because this then establishes the idea that fractions can be numbers as well, and that allows us to do 3/4 or 4/5 or whatever. But we're going to take you through some ideas about what you can do, starting with young kids, to develop a concrete understanding of fractions. A post-it note. Let me know if you haven't. There should be enough for one each. No expense spared. Here you get extra. This is one of my favorite activities I do with grade 2s or grade 3s. And they always do it really well, no pressure. Okay? So what I want you to do is fold it in half. Now fold it in half. And now unfold it. And paper folding is fantastic. If you've got anyone here who likes origami, this will be like common knowledge to you. But we've created basically some fractions. Now what I want to know is, I want you to compare your fractions, talk about what they are, to people next year. Do you have same folds? Okay? Have you all got the same fold? Or something different?
But what I like is that now that you've started, you now are thinking that you could have, and you're trying to refold, and you're imagining that part in your head, right? So that is also how we develop fractional understanding, is when you've had these concrete experiences, and you get to think about them.
So it's triangular. Oh, or folded like, yes.
Fold it horizontally and then vertically.
And that's okay.
It's not illegal. That's fine. And you get your fourths or your quarters that way. And we can talk about why can we call them fourths. Okay, there's 4 of these equal parts that make up one whole. So we're going to define, this is really important in fractions, you have to define what the complete whole is. The complete whole was this post-it note. But there's different ways of folding it. If you fold horizontally and then horizontally again, you get these. And so your fourths are kind of like these horizontal ones. Now we know that some students but don't believe that these are fourths because they look different to those fourths. So that's a big misconception, that you can still be equivalent to each other even though they don't look the same. Did anybody do it a different way? Yeah. I'll just nab that off you. Thanks very much.
Really, I saved the whole presentation.
You can do it this way as well, diagonally. All right. So now our fourths don't look rectangular at all. They look like triangles. And this is mind-blowing for some kids. And it takes you a lot of convincing that, no, these are still fourths. Sometimes kids expect, the fourths to look like rectangles. But no, those are fourths. How do I know? They're all equal. And there's 4 of them, and they make a whole. That, by definition, is what a fourth is. So we can do a lot of really good work just by simple paper folding to get kids to understand why we call them fourths, why we call them fifths and sixths, and so on. And other fractions, maybe people on your table or on your seating area, and ask yourself what fraction of the people are wearing glasses.
Wearing glasses, yeah.
This is your area
So
here. Okay?
So in this set of people,
This is your area here.
Yeah.
You guys.
Zero
This is your
thirds,
area.
right? Yeah. So if we wanted to rate and even to talk about like how can you guys look different? Like, you're a third, you're a third, and you're a third. Right? Kids are like
What fraction?
they're trying to figure out that set.
Oh, right now.
Oh.
now is. Everyone else gets the wrong answer. Oh, no, it's a half. Oh, I see. I see how it goes.
I see some people putting glasses
Yeah.
on and off.
Fooled ya. So we can have fun with that, and there's all sorts of questions. What fraction are female? What fraction are wearing blue? What fraction have had tonight? I don't know. But it's that sort of thing. But the idea here is, in this particular case, we're not all the same size, are we?
We'll leave it at that.
We'll leave it at that. Yes. Are
I'm
you
just
saying I'm short? Is that what you're saying?
I'm just saying that if we were a set,
We'll leave it at that. Okay. So, but this is really important, that we have to give kids opportunities to experience fractions as a set and fraction as an area, and then later on we'll say, well, where or quarter on a number line, so they get this idea that a fraction is a number as well. There are other things that we can use to help establish this, and unfortunately we don't have enough. But you'll see these used an awful lot in primary and even junior classrooms as well, that you can use. Say this is one whole, so is this. Oops. And if the yellow is defined as one whole, what is the blue? And hold up to kids and say, what do you think? I'll get them to make a prediction, and then they'll have the fraction blocks, and I'll say, prove it. And they'll put another one on, and another one on, and if there's 3, we'll say, right, that's why we can call them thirds. Even in that language, third, and fourths, and fifths, they're not really good for actually learning what they are, because we're using positional language, like the language you use in a race. I finished third, I finished fourth, I finished fifth. In other languages, what they use is much better, more powerful. They'll say 1 of 3 parts, or 3 or 4 parts. So there's built-in quantity understanding. So I think certain Asian languages are like that. And I'm pretty much convinced that gives kids a little bit of a head start when they learn about fractions. I've got to show you another fraction misconception, which I just remembered.
let's ask a student, what fraction has been shaded? And this student said 1/4. Why? Because it's the fourth one in line. Yeah? So sometimes our language isn't very good to help us learn about this. I mean, eventually we kind of moved her on, but so our next thing. Oh, yeah. Can you do this?
Well, I think if you just said that,
Yeah, I
that
think
way,
yeah.
it's kind of rude at this
Oh,
point
but
to
it's
say,
it. So
yes.
we are play a fraction game. It's called Fraction Chomp. We are going to give you one of these game sheets each, as well as a dry erase marker. So, do you want to give those out? One per pair, yeah? And as it's being given out, I'm going to ask for a volunteer to come and play this game with me.
It'll be in pairs, but.
We're not playing for money. Much. So this is a bar of chocolate. And what I'm going to say is that this bottom bar is pointless. That bottom piece there. Okay? We're going to take it in turns. It's a bar of chocolate. We can snap off complete rows or complete columns. And we'll signify that just by shading them. Okay? If you force me to take this piece, you win, and vice versa. Okay? You go first. Complete rows or complete columns. Alright? Just like a chocolate bar, snapped off a complete row. Lovely? I'm going to snap off those two columns. Okay? Okay? Okay. I'm going to do that. Do that. I do that. That was more by luck than judgment, I'll tell you that, okay? So in that case, my opponent eat a poison chocolate piece, so I win, okay? Does that make sense? Right. The little twist we're going to put on this is, after you break off each piece, write down the fraction that you've broken off. To illustrate the first one, what fraction did you break off? 1/4. But I will also accept 6/24. Okay? Then I snapped off these bits. What fraction did I snap off? Okay, I'm going to agree with 1/3 because of the remaining piece, not the original piece. Do you see why we're doing this? We're talking about the fraction of the whole. We've got to define the whole, and the whole is changing each time. Okay, so in this case, you can see this. I guess those are 3 columns, so that would be 1/3. Some people might say 6/18. And then my friend did this piece. That's again a third of what was left. Then I did this bit. Half. Half again, yeah. And then I did half again and got that. Okay? So that's what we're going to ask you to do. Alright? Off you go.
Can I videotape you guys playing this? Sure. Awesome.
All right, I think.
Third. So what was that?
1/3.
1/3. Perfect.
Okay. Oh, so should we do, so I guess.
Oh, you're gonna put that.
Do we have to do it?
Yeah.
Quarter?
The first
Quarter?
one was 1/6.
Yep.
1/3.
Okay, and then we'll do this much here.
One half.
Oh, yeah. She got me anyways. It's all about trying to.
Nice.
Good luck.
I think you're dead. I'll take off a half.
And, oh no,
Oh, you-
no,
you-
I
playing
can
it
take
out.
off a half.
Oh! Just when you snatched the thing from the jaws of victory, didn't you, eh?
We got a little coffee there.
So, Mike, what's your strategy when playing this game so the parents can beat their kids?
What's the strategy? I haven't developed one yet, okay?
All right.
But
fair.
I do like to get, if I can get to the 2x2 square at the bottom, that's really good for me.
Okay.
Yeah, so it's totally up to you to understand that you can do more than one row or more than one column. I did not know that. I lost to Mr. Jenkins.
Okay.
Now, after a while, I think you might begin to develop certain strategies. I know when we first,
Do we have to talk?
well, let's say with somebody, Christine. I think Christine took all of these columns off, and I just took these off, and she was forced to do it. So it was a very quick game. But you learn strategies very, very quickly, and after a while, it might be a bit like, is it tic-tac-toe or X's and O's? That you kind of know what the good moves are to start with. When you get to that point, you can then play the variation. So instead of snapping off complete rows or columns, you can snap off 1 to 4 pieces as long as they are all in a line. Okay, so you can't do them diagonally, but you could do, say, 4 in a square or whatever. But you don't have to snap off complete rows or columns. And that really does open up there, and I haven't got a clue what the winning strategy is there. But each time,
We could work together, right? We'll work together again.
of course, I could just be hustling you, you know. But each time, what we're getting at here is that I really want not just to play the game, which is kind of fun in itself, but a great thing to practice, write down the fraction each time. Okay. Just as a little tip, one of the things that I might do, you might not have this with you whenever you go out, but if, say, you're waiting for your food at the restaurant, it's the simplest little thing. Just draw a 4x6 grid, put skull and crossbones on there, and play that with your kids. Okay? And whilst you're waiting for your food to come, it's just a great way of keeping them kind of engaged and also doing some math. Win-win.
Because definitely Yeah, or you can just take that. Couple things. First of all, you could just have the strategy game, right, and not have the fraction part, like even if you didn't get. So we here are being really mindful of being in that fraction. So you, if you wanted to have your grade 1 child playing this game, it could just be the strategy game that you play. But then we were really talking about this whole idea, we have to identify what the whole is. And the whole can change. So then we talk about that. Kind of an organizational. So these are just page protectors. So if you know of a game or you have something like that, or something comes home from school that you kind of like, and then a whiteboard marker, and then it's quite easily to reuse.
Okay, so your experience or when we were talking about the folding of the paper, that was a concrete experience for you. And we talked about unit fractions with that. So we talked about what 1/4 would be, and we kind of went from there. You've also now just had a diagrammatic experience. So you've looked at a diagram and you kind of worked away at it. You made the changes and those kinds of things. Diagrammatic can also happen on the computer. So you are going to get this site in your materials this evening. And what this site will allow you to do, it will allow you to create fractions. So it decides what the whole is for you. And when we're going to compare, that's really important that the wholes are exactly the same. So this kind of does that all for you. It does it in rectangles. And in this site, you can add various bars here, and then it will help you to go through. And by selecting these up and down arrows, I can now divide this fraction bar into 4 pieces, 5 pieces, all the way up, I believe.
100.
Okay, so you can, it's really good for keeping those.
So it's just a nice way. If well, let's go back to the people who thought that 1/3 was less than 1/4.
And you can see that whole number understanding. We know that 3 is less than 4, so therefore that's kind of where that whole number understanding affected that whole burger situation. But when we look at what happens when we're comparing 1/3 with 1/4 of a whole, you can see very precisely that 1/3 is bigger.
It allows you to do things fairly quickly, seeing things like 2/7 is bigger than 1/4, bigger than, not quite as big as 1/3. Okay, and again, it's just a diagram just to get kids familiar with unit fractions. And then
the other thing that we can do when we are using that diagrammatic, we can talk to kids about how you count with fractions. So whole number, we also learn to count with fractions. So we might say something like 1/4, 1/4, 2/4, 3/4, 4/4, or you're going to say say something like 4/4 or 1 1/4.
now this idea of skip counting by fractions is going to be really important later on when we start doing division by fractions, and you'll see what I mean in about 20 minutes time. So stay tuned. Don't turn that dial. Okay? We've spoken about that. So now we're going to do a bit more work on comparing fractions. And as I said earlier, let's say this is 1 whole, and you're happy that this is 1/3. What would happen if I have 8 of these? What would they look like? Just talk about that amongst your tables for 20 seconds, 1/3 of a minute. I imagine most of you have got the correct answer. Okay. I think one of the worst things I could do is give us some. Eventually, But what I will do is, if I had enough of these to show you, I'd actually give them 8 of these and say, right, with 8 of these, 1, 2, 3, what do we make? That's 3 so far. 4, 5, 6. I've already got 2 holes. Do you see that? I need 2 more. 1. So look, 8/3 is equivalent to 2 and 2/3. A bit more experience with that, kids start to develop the rules themselves. Oh, it's a bit like division here. I see how many 3's go into the 8. 3, 6, and I've got 2 left over. So the concrete experience is really important for them to start making these sorts of comparisons. Does that kind of make sense? Okay. Going back here. And we are now going to give you another puzzle. So you can get similar puzzles at this website, fractiontalks.com. Of challenge to our junior kids. And we've got different sections in that square. What I'm going to do to begin with, I'm going to define this complete square represents 1. Okay? And what I want you to do is to figure out what fraction you would give each of those parts. Okay? Again, this is not an exam. You can talk about it.
Well done. Top marks. Oh, I beg your yeah, so, yeah, that's exactly. Tell me what fraction each of those parts is. Yeah. I really like what you're doing there for that paper forward. Yeah.
This is a half. So do I just, what do I do that?
Okay, so when you sometimes get this, is that you would say, well, there's a half there, so yes, that's good. But I want these individual pieces. Yeah, but that's a really good question. Just going to take a wee photo of that information. Awesome, thank you very much. Yeah,
That was very
great strategy. Yeah. You can put that on the fridge. Yeah. So, yeah. Awesome. But again, the lovely little strategy there to subdivide it. It isn't as obvious for some of our kids, and sometimes they're almost like begging permission. Can I do that? Yeah, you can do that. Yeah. But it all goes back down to those unit fractions. This bit here, when you divide in that, and you say, okay, it's a quarter of that, each one of these. Oh, now there's 16 of these. There's 16 in the whole thing. So the unit fraction is really important. You done, eh? Yeah. Yeah. Beautiful. Yeah. Again, it's like some kids, they're not like, fully convinced that they can both be quarters. You say, well, no, that's your
I did it the other way, so they just might just start doing it that way instead.
Yeah.
They're saying, let's look at it a different way. I mean, let's look at this way, so it's easier to visualize. Oh, I see. So you have to work the quarter, that kind of thing. You know what I mean? The long way. When we actually
yeah.
to like
Yeah, it's-
have it a numerator.
The square
That's
much more powerful. And like I think in North America,
but they are expected to divide the shape in half, or like so they know that it has to be equal parts, but it has to be like it has to be number in the set. So they're doing lots of it. It's they're doing fractions of it like that complete experience as opposed to.
we good? So I don't even need to show on the board there. Lovely. I tell you what, it's seeing all the different ways of approaching that just gave me math bumps. Okay, math bumps a bit like goosebumps, but you get them when you do math. Okay, it's like, oh, what's that? What I really like is the different strategies, and really when it comes down to it, you're basically thinking about unit fractions. I think you all saw that as a quarter to begin with, yeah? And they said, oh, that's a bit like the diagonal quarter back there too. And then you're saying, well, that's like half of a quarter, so you're using that unit fraction of 1/8. And then you figured out, well, if I draw a line across there, and that's a fantastic strategy, draw the lines on. We'll talk a lot more about this in our spatial reasoning session next time. You can then say, hang on, there's 4 there in that quarter, there's going to be 4 more there, there's going to be 4. I've just created 16ths. 1/16, 1/16, and then you go 1/16, 2/16, 3/16, count with fractions. If that doesn't touch your crumpet, I don't know what will. Okay, so
Well, this might toast your crumpet. I liked how people were making the connections to the paper folding that had happened before, right? And the fact that even when somebody gave, that people convinced themselves of it. So, shit part.
So now we get to the fun part where with enough experience, we don't need a concrete model. We don't need a diagram. We can just use the visuals in our head to figure things out. Which of these is bigger, 8/13 or 5/13? 8/13. Okay. Which of these is bigger? 3/4 is bigger. So sometimes we use the fact that we've got like denominators. If they're the same, it's very easy to compare the numerators. But other times, if the numerators are the same, we don't need to do anything else. We can just look at the denominators and say 3/4 must be bigger than 3/8, because 1/4 is bigger than 1/8, so 3/4 must be bigger than 3/8, without doing anything else. Then we get to this point where they are unlike, and that's when we can work symbolically, because we've got a great foundation. And with enough work, we can say, well, if I had a diagram, what might I change the 8ths to? What might I change the 12ths to make it a bit more like this, where there is the same denominator? 24ths sounds really good. If you use that kind of butterfly method, you've got to work with 96ths. Yeah, not so good. It will work, but not as good. Okay? And here we've got 24ths, and then now we've got 7/12ths, and I've done lots of work with my fraction chomp game, and I'll know that that's equal to 14 24ths. And I've got 5/8, I know that's going to be 15. Or, you might have seen it before, but now it's much easier to compare. 15 24ths bigger than 14 24ths, therefore 5/8 is... Is that right? Okay. You want to do the next one?
Yes, absolutely. Okay, so when we were talking about that continuum, so we've talked about the unit fractions, we've done some work with comparing fractions, so now we're getting into that operating with happens towards the end of elementary school, and it works all the way into high school then. So again, when we are adding fractions, we want kids to have an experience where they are using concrete representations. And in an ideal world, this board was magnetic. But it It was kind of disappointing for us. So, just like you, we make things up, kind of go with,
I thought you said I was disappointing. You said it's disappointing, just like you.
wow, I should really watch where I pause there. Especially with witnesses. All right, so when we are looking at this, we're seeing 5/6 plus 5/6. So a misconception that can come is that somebody would say 10/12. Why would they say 10/12? Because they're using understanding. You add and you just keep going. There's a 10 over a line where the 12 is underneath. So Mr. Jacobs is showing for us using our fraction bars 5/6 plus another 5/6, and then we can actually move, and now we know that 5/6 plus another 5/6 is equal to 1 whole and 4/6. So there's that concrete experience again. So again, something like the virtual manipulative that we were showing to you could be something that you do diagrammatically with them. Now, another little tidbit, we often simplify fractions. We wouldn't leave it as 4/6. And so the word we use is simplify. We don't say things like reduce, because if you're reducing something, you're making it smaller. So when I simplify, I can say 1 and 4/6, or I can say 1 and 2/3. If I reduce something, you can see where that sometimes isn't the correct language. So even to simplify is the word that we prefer. All right. So that was all great when they were the same kind of fractions. So what happens when we have something like 3/4 and 1/2? So again, I can put up the 3/4 and 1/2.
It's really sticky.
Oh. And it's really important, again, if you're doing it sort of that visual, is to have that whole so that they know what the whole is, especially when you're getting to smaller and smaller fractions. Okay, so we know that 3/4 plus 1/2 is equivalent to, or equals, 1 and a quarter. All right, so then if we wanted to go into that continuum again, now that we've done it concretely, and again, the rectangles are sort of the best model for that, diagrammatically, we can go into what 3/5 plus 3/10 is going to look like. So Mr. Jacobs here has put 3/5. He's created tenths. And now it gets kind of awkward because, and I can see some of you are kind of like figuring out where that is going to come into play here. Some of you are trying to put this up there. So we are at the point where we need to have some sort of common denominator now. Okay. So when we have here, we have our original 2/5.
3/5.
Or sorry,
3/5.
3/5. How you're looking at something and you see it, and then your brain says something else. Yes. So then we can add our 3/5 and our 3/10 because now we've made a
Even say, do you all agree with this statement? Okay.
Good. Then you can't possibly agree with it because you can't see it. Absolutely.
Oh.
So what it says, and I'll say that also too for the people that are at home, Mr. Jacobs is wondering if 3/5 plus 3/10 is the same as 6/10 plus 3/10. Okay, and so then that is how we got to our 9/10.
I think at this point, one little tip I would give is that whenever you're doing any sort of fraction work, it is really, really helpful to going down the page. It's something I really encourage all my students to do because I can see that this is the same as that, that is the same as that. Sometimes kids want to work going across the page, and it's a lot more difficult to keep track of what fraction goes with where. Okay, so working down the page pays dividends. And then once we've got enough experience with that, there comes a point where you know what? We don't need concrete materials. We don't need diagrams. We can just look at these and say, I wonder what the best denominator is going to be. And I think in this case, you're already thinking a number that 5 goes into and 4 goes into is 20ths. That makes sense because we've got lots of concrete experience to put it on. I can change the 2/5 to 20ths and the 3/4 to 3/4 to 20ths and go from there. Okay? Concrete, diagrammatic, symbolic. Right, quick question. You ready for this?
Yes.
One person. Great. Okay? So I'm going to flash up quickly, and I want you to just turn to your partners or the people on your table and say the answer really quickly. Okay? No pencils, no working out. Ready? Oh, wait. Are we ready? There we go.
So for those of you that don't have, we have 2 2/5 divided by 1/2.
I'm not going to give you the answer just yet. But I know a lot of you want to write something down. Okay? And this is my point. It's that we've got to sort of question the way we've been taught. And I know a lot of you can divide fractions. Okay? But what I'm wondering about is, do we understand what it means to divide by a half? So this is my goal, that we understand what dividing by a half is equivalent to, what dividing by a third is equivalent to. And we're going to do that, concrete, diagrammatic, symbolic. And we're going to start, just for fits and giggles, we're going to start with multiplying. We've already done this to an extent. I'm going to do a half times a half. Okay? I'm going to fold my paper in half. This is a drawback.
I was gonna say, did you put the sticky pieces together?
Right, you folded that. So there's a half. Okay. Now I'm going to do half of that. Let's shade the other way. And the bit which is half of a half is a quarter. So just with simple paper folding and a bit of shading, we can get kids to understand half times a half is the same as a quarter. That's really powerful. A half of a half is a quarter. All right? But it becomes difficult to do anything much more exciting than that. Okay? Because what can we fold easily? Halves, quarters. Well, they get a bit boring after a while. So what we're going to do, we're going to use diagrams now to do something like this. 3/5 times 3/4. Okay? Now, I'm going to decide to use a diagram like this. And as a teacher, this is how I'd go through it. So I've drawn my diagram, and I split it up into fifths going this way. Okay? And in preparation, I've also split it up into fourths. And I can see you're already twigging on why I've actually done that. Okay? Do you agree that's 3/5? Yeah, of course you do. Do you agree that's 3? Yeah? So the beautiful thing about this is that this connects to all the work they've done on multiplying, which is basically an array. Think of 2 groups of 3. It's like a carton of eggs, 2 3s. Well, it's the same with fractions. This green section here is 3/5 of 3/4, or if you want, 3/4 of 3/5. So let's have a think. What fraction is that? Well, unit fractions.
What is one of those green squares? 1/20th. Okay.
Yep. Great.
Good. Thank you. So we've got 1, 2, 3, 4, 5, 6, 3/5 times 3/4 is 9/20. Okay, a little bit less than a half. Yeah? So, how does that look? Well, with a bit more experience and a bit more diagrams, kids can kind of see, well, the 20th comes from these two numbers. How do I use those two numbers to get the 20th? What am I doing? I'm multiplying. And how do I get the 9? I'm looking at them two numbers, aren't I? And there comes a point where kids look at us and say, do I have to draw that blooming rectangle anymore? Or words to that effect. I say, no. You're now ready for the symbolic. So there comes a point where kids say, I know why I've got to do this. I know why I'm multiplying the numerators and why I'm multiplying the denominators. I know why I'm doing it for this and why I'm not doing it for adding and subtracting fractions. So you see that concrete, diagrammatic, symbolic. I want kids to get to this stage, make no mistake, because you know what, we can do a ton of fun with this. And this is really powerful when we get into some algebraic fractions, like, well, I'll say fun. Fun as algebraic fractions can be, okay? But when we get in there, this is a really efficient way of doing things. Okay. Have you seen that before? Did you understand that's why you do numerator times numerator, denominator times denominator? That's something. This is not, all this stuff we're doing tonight is not classified information, okay? Take it home, share with your neighbors, but especially if your sons and daughters get stuck, go through this concrete, diagrammatic, symbolic continuum, okay? So, one of the biggest misconceptions I know, not just for students but for adults as well, is that when they read this, they read it this way: 2 2/5 divided in half. The dividing by half isn't the same as dividing in half. I'm pretty sure some people here would have come up with an answer 1 1/5. Okay? But what does it mean to divide by half? That's a good question. I'm glad you asked. Let's go through concrete, diagrammatic, symbolic. Okay, so if we had enough of these pattern blocks, I'd say one of these hexagons counts as one hole. You okay with that? You can see I've got 5 holes there. I'm going to see how many of these halves go into these 5 holes. Look at that. Have a quick think. Visualize what's going on. And you tell me how many of those halves go into the 5 holes. What is 5 divided by a half? You know C10? Yeah? You see something like that. Happy with that? What if I did 5 divided by 1/3? How many of these go into 5 of those? Now, of course, if I'm dealing with kids, I'm given the concrete materials. Okay? 15. Okay? What about, I'm just making this up now, that 5 divided by a tenth? Go into. So now I can get them to think about the pattern. Would you agree dividing by half is the same as multiplying by 2? Dividing by a third, same as multiplying by 3, and so on and so on. So dividing by 1/n is the same as multiplying by 1n. So if we go back to our original question, there.
No, I think the like the dividing by a half is the same as.
Oh, sorry, like that. That one.
That one.
That one. You're welcome. Very good. But now if we go back to the original question, what was it? 2 2/5 divided by a half? I don't need to do any pencil paperwork. If I understand dividing by half is in fact the capital of Dublin, sorry, the capital of Ireland, Dublin, okay? It is just, I really messed that one up. It is just 2 and 2, I'm Dublin 2 2/5, that's 4 and 4/5. Okay, and I think that a lot of us might have missed that experience. That's the effect of dividing by a half.
but it's going to be more powerful now because I'm going to use diagrams. Do you remember we skip counted by fractions? Okay, well, we can skip count by unit fractions, but we can also skip count by non-unit fractions, 2/3. Again, we're going to do this for fits and giggles. 4 divided by 2/3. It means how many jumps 2/3 can I do starting at 0 before I get to 4. So you can say 2/3, nice diagram here to help you. 1 1/3, 2. At this point, a lot of kids say, well, another 3 jumps will get it. 6 jumps all told. Are we quite happy with that? And I will do a few more examples like that. And then I'll say to kids, well, what is happening? What is dividing by 2/3 the same as doing? You started with 4, you ended with 6. Dividing by 2/3 is the same as multiplying by what? By 3 divided by, or by 1.5. Okay? And with a few more examples, you can see where I'm going with this. I'll say divided by 2/3 is the same as multiplying by 3/2 or 3/2. Okay? Divided by 3/4, same as multiplying by 4/3. Divided by 4/5, same as multiplying by 5/4. Divided by A beats is the same as multiplying by B divided by A. So what are we doing when we divide by a fraction? We're inverting and multiplying. Okay? So it's one of the most common questions that kids or even adults will say, why are we doing that? And like in the past, I might have said, look, you just do it. It's a rule. Just memorize it.
Oh no, but there's a cheer,
Hey?
and there's a cheer kind of
cheer?
thing. Yes, yours is not to reason why.
Oh, ours is not to reason why, just invert and multiply. Yeah. But with enough experience of this now allows us to do this. 5/8 divided by 3/4. Because I listened carefully to Mr. Jacobs, because I respect him so much, I'm going to show my working out beneath. This is the same as 4/3. And now I can say 5 times that is... Who said 24? Who said over? Who said over? We don't say
It
that.
was me. I'll take it. It was me.
We're amongst friends. We can get away with that. 20/24. Is there anything we can do with that?
Simplify.
Well, you said simplify. We didn't say reduce. That's fantastic. You guys are the best. Okay. What's it? 5/6? Is that right? There are other techniques that I will show later on where we can do some things here. Something called cross cancelling to get there. But that's not my goal to begin with. Okay. When I think kids are ready for that, I will show them that. And that saves them working with bigger numbers later on. All right. So I hope you understand is that this is what we're kind of aiming for. I really want kids to divide by fractions. And you know what? I think it's really powerful if you can do it symbolically. But whereas in the past when I taught, I jumped straight there. And I lost a lot of kids because they didn't have a foundation to build on.
And a common misconception, they'll invert the wrong fraction. Right? Yours is not to reason why, just invert and multiply. Okay, well, I inverted 1. I did, right? So they won't have the understanding. They'll just blindly apply a procedure.
We hope you can take all those ideas, and when your sons or daughters maybe get a bit stuck with whatever, you can go for that concrete, diagrammatic, symbolic explanation. I think the last thing we've got to share is other things you can do at home to help your sons or daughters. First, measure. Okay? Tape measure, and you might not be building anything, but you know, just give a tape measure to your son or daughter and say, just go and measure some things. Okay? And you know, I don't mind if they're measuring in inches or whatever, but this is, this 36, you know? 36 what? 36 elephants? No, 36 inches. Okay, and then you do another one. Here we go. And there'll be a point where they say, oh, it's a bit more than 72. Well, how much more? 72 and 3 bits. What do you mean 3 bits? 3/4? 3/8? Well, let's look more carefully at it. You can show what 3/4 looks like, or 3/8 looks like. So it's a ton of fun you can have with measuring. So if you're doing any
Constructing?
thank you, around the house, okay,
Charades.
get your sons or daughters to help you with that. If you're doing any cooking,
Yes.
measuring cards, absolutely fantastic. Get to help.
And it's really great for counting fractions. So 1/4, 2/4, 3/4. So when we've worked with kids and you're talking about it, right, and you make that gesture, you'll see kids are like, I've done that with somebody, right? Can see that kind of understanding. Clocks. So not just your digital, but your analog clocks. So you think about how that would help with fractional sense. So the quarter past, of those types of parts of it. So using that analog clock.
Yeah, even things like sometimes certain things in baseball they might say 2 2/3 innings and that sort of thing. Estimating, just getting a rough, a rough idea. This is about 3 feet. It's a little bit less than 3 feet. Even just counting money. So, like we said earlier, if you got like a jar of silvers, okay, tip it out, say, count this for us. I think we'll end with this. Give me a thumbs up when this makes sense.
Hint, think about Mr. Jacobs' sense of humor.
It's actually not a math problem. Do you like Dr. Seuss? How would Dr. Seuss say this?
We over here?
What do you got?
I told you to think
You're
of a sense
welcome.
of humor.
1/5, 2/5, red fifth, blue fifth. There you go.
There you go.
Thanks very much for coming out tonight. I hope you found it useful. I hope these are some things you can take home to help your sons or daughters. And also, again, sharing with our next session.
March 19th? Yes.
Beware the Ides of, is that the Ides of March? Yeah. Is that All
It's at All
Saints?
Saints, yeah.
Okay.
Spatial reasoning.
Spatial reasoning. It's one of my favorite topics. Okay. Bring a friend. Thanks very
Excellent.
much.
Thank you very much.
Have a safe journey home.